Hey guys, welcome back to the channel. Today we are going to be doing a mock Google style coding interview with a Google software engineer here, Jay. Jay, would you like to introduce yourself to the YouTube channel?
Hey everyone, I'm Jay. I'm a software engineer at Google. I had interned there 3 times in the past and currently working there in a full-time capacity.
Okay. Exciting, exciting. We're actually going to see how a Google engineer walks through a coding interview today. So, you ready?
Yeah, let's get to it.
Let's get into it. All right. So, the question I have for you here, Jay, is you're an explorer sailing across a vast map made up of rows and columns of tiles. Each tile is either land, represented as a 1, or water, represented as 0. Land tiles that are horizontally or vertically connected form a single island. Diagonal connections don't count, only north, south, east, and west matter. Your mission is to count how many distinct islands exist on the map. In other words, given the grid representing the map, return the number of separate land masses you can find. So I have an example there. You're going to be given a 2D array, which represent a grid. And for this exact example, we will be returning 3. Because the number of islands is 3.
All right. So this is the input, this is the output. Okay, can I ask some questions about the inputs?
Yeah, go ahead.
So first of all, is this a list of a 2D array of strings or a 2D array of numbers?
You could assume it's a 2D array of numbers.
And there will only ever be numbers in there.
Yeah, it would only ever be number 1 or number 0.
All right. Also, is there for the grid, can I assume that the number of columns will be consistent across like rows? So
Yes.
I would have something like this.
No, you wouldn't. Yeah, it will be consistent across the grid. You'll have n rows and m columns.
Okay, consistent columns, consistent rows.
Yeah.
All right. And is it for the inputs? Is it possible that I would run into a situation where there are no islands, or will there always be one island?
Yes, you could. Yes, you could. You
Okay.
could be in a situation where the list is empty.
Okay, yeah. List is empty, or maybe it was just like an all 0. Like it was all
you can
zeros. Yeah,
you can have both too.
So yeah, I guess one way we could tackle this is we would start at the first element in the input, and then we'd run through all of them iteratively, right? And then every time we come across a piece of land, okay, the land is 1, and then the water is 0. Yeah, so every time we come across a piece of land, we'd basically like explore that land, like a pirate, basically. So we would we start here, and we could use depth first search or breadth first search. Probably for this problem, I would go for depth first search just as a matter of preference. But yeah, so we would start in this first piece here. This is a 1. Then we would go down. That's also a 1. We would go down and down, or we'll go down 1 more, and then this is 0. So we just stop here. There's no point going any further because like that part is gone. Then we know, yeah. Then after that we would go right. We'll go in all directions actually. So down, right, because it says down, right, up, and left, and it says in the question that we won't, like, diagonals don't count as being connected.
Yeah.
So only in like all 4 directions. Okay.
Yeah.
So yeah, and then we would do that. Here would go right, then we'd go down again, go down again, and then we'd run into a case where we've seen some water, so there's no point going there again. Go back up, right, some water. Same thing here. We'd go water. Just for the purpose of the example, I didn't go up and left, but basically when you would get to something like this, if you would go up, that's actually something we need to consider, which is we need to make sure we don't visit pieces of land that we visited before. We don't visit them again. So down here, if we're going in all directions, we would go right, we would go down, but we would also end up going up and left again. So in that case, let's track basically the pieces of land that we're visiting, that we've seen. And then if we come across a piece of land that we've seen before, we'll just ignore it.
Okay.
We'll
Okay.
like we'll just break out. Yeah, how does that sound?
Yeah, that sounds like a pretty good approach.
Um,
Let's see how you code out then.
all right, so I'm going to use Python or Python-like syntax. Hopefully, hopefully I don't run into any like syntax stuff, but they should be mine.
I do have one question though.
Yeah,
As we process each land and we what's it called explore it like a pirate, as you said,
yeah.
what are we doing once we hit a cell? Like, let's say we hit the cell 00. Once we hit that cell, what are we doing? How do we know? What are we doing with our counts? Are we doing anything, or are we just exploring and that's it?
Okay, so when we hit the first piece of land, if we've not seen that land before, right, we explore it, and then right immediately after exploring, we'll just increment like a variable that says, okay, we've hit some island, right?
Okay.
And basically, the goal here is that when we hit here, we would go, we would start here, go right. Basically, we'll find all of this, and then this whole patch over here, if I can just like highlight
I don't think
this.
you can highlight it. Like, yeah, yeah, that's good.
Okay, yeah, this whole patch, yeah, this whole patch would basically be marked as like seen, right? So
Hmm.
we would go one, like if you think about the iterative approach, it would be like 1 1 0 0, like all of that, right? But things that
Hmm.
the first time we see a piece of land, we basically halt that iteration and then explore that land, right? So that means when we go on to the next one, we wouldn't explore it because we consider it as part of some land that we've already seen,
Okay.
right? And then once we start exploring a piece of land, we just say, okay, we've seen an island. It doesn't matter the size of the island, but we have seen an island, so we just increment by one, right? And then
Okay.
yeah, so we would stop after exploring. We would continue on one. Okay, that was part of some island. This is water. This is water. This is water. We come here again. This was part of an island. Ignore it. This was part of an island. Ignore it. Water, 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 water again, water again. Oh, we came across this one, but we came across this one and it's a piece of land. So we're looking all four directions, up, down. Oh, like these are all like water, so it must be alone. So we've seen that. Then we continue on going 0 0 water, 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 water. We'll come across this one. Uh, we'll go in all four directions, right? Here, here. This is also okay. That's also a piece of land, and then of course, like we continue on every time we see a piece, right?
Hmm.
Uh, but here we've hit like we'll go right down here. We would actually look left again, but because we've already seen it, we'll just ignore it. And maybe for the purpose of this, let me just use different colors.
Okay.
Right. So then, yeah, so would out of bounds, water already seen. So those would actually be our base cases.
Okay.
Yeah, because I think I would use depth first search. So probably I would just go with recursion here. But you could do this iteratively with like breadth first search as well, with like a queue or something. Yeah.
Okay. Could you tell me why you're going for a depth first search and not
Just
a breadth first search?
just preference.
Preference?
Yeah, just
Okay.
preference.
Go ahead.
Um, so yeah, so let me get started on function. But how does that solution look to you?
Yeah, it makes a lot of sense. Just want
Yeah,
to see how you put it together into code. Yeah.
yeah. So let's start by defining a function, and the problem here is to find the number of distinct islands. So let's call this non-distinct islands, and it takes an input. Yeah, let me just use some type annotations. I think in Python it's int actually.
Yeah, should be.
Yeah. Can I tab in here? Okay. Yeah.
Yep.
So I remember you said it's an n by n grid, so columns and rows are consistent.
Mm-hmm.
So let's start by defining the number of columns. Yeah, I'm just gonna leave the capital letters. length of input, and then the rows is rows equals name input of 0. And actually, I do realize that we have a bit of so basically we need to check here because we're trying to access the first element of the input, which would be like an array. But if the input is empty, that would actually be an error. So we need to check if input, if not input, this would, like in Python, this would be equivalent of like in other languages would be like checking input.length equals 0.
Okay.
So if not input, I am messing this up. Okay, yeah. If not input, yeah, we just know there's no islands, so we'll just return 0. Yeah, and then we can continue on from here. The next thing I would want to define is, let's track which like columns or rows we're visiting with a set. I'm going for a set here because it has constant time access.
Okay.
And lastly, okay, of course, like the number of islands. And then we'll just set that to 0. And then, like I said early on, like to start with, we want to run through like every element like in the flattened input, right? So to do that, we use a nested loop for row in range. No rows actually. And then we'll check the columns for call in range. Num calls. And then basically here we'll say, okay, let's just define two variables. That's is visited is whether we've seen this row and column before, and that we could just do row call in visited, because we're going to be storing like the tuple of, so this set, I'm not sure if this is how you define it in Python, but it would just basically be set of tuple int, right?
Mm-hmm. You don't need to worry about typing too much. Don't worry about that.
All right. Then the next thing we want to know is this land, right? So grid of row call equal to land is 1. Okay. Equal to 1, right? So if we've not visited this before and it's land, because those are the only conditions we really care about. If we run into water, we don't really care that much. If we've not visited this before and it's not land, let's say explore. I'm just going to append DFS just so it's like clear that I'm using DFS. So explore DFS row call, right? And then, or actually, yeah, we know we've seen, basically this means we've seen the start of an island. It may be the only like piece of land in the island, but we've seen something that might indicate an island here. So we'll say islands. Did I define that variable? Okay, yeah. Islands plus equals 1. Visited. And then now we need to define this explore DFS function. We need to define that. So explore DFS row call. Okay. So this DFS approach is going to be like recursive. So I guess we could start firstly by defining the base cases. Base cases would be out of bounds. So let me out of bounds. if rho is not toe, if rho is less than 0 and or call is less than 0, that would basically define like, okay, if we're over here or like we're over here, right? That's like -1. So the next thing is if we're like out on the right side. So or rho is greater than or equal to num rows, or call is greater than or equal to num calls. In that case, we would just like return like no point exploring further, because like we would even run into errors trying to access the input.
Mm-hmm.
Right. The next thing would be if like the row and column combination is invisited, return. Maybe I could just move all of this, or actually I'll just continue. And then the last base case, so this one above is already seen. And that would help in the case of when we go like up, left, like we go backward basically. Yeah. Then lastly, if this would be the case of, yeah, we see water. We've seen water because that marks the end of the island in this current direction. If input row, actually I just realized that I used grid here. This should be input. If input row of call is equal to 0, 0 is for water, yes. Then we will return. So these are from what I can see our 3 like base cases.
Okay.
And then the next thing I want to do is effectively say, look, we've explored this part. Don't bother coming here again. I think I can do this in Python row call. If not, I guess just put the tuple in there. Yeah, so we'll say, yeah, we've seen this. And then now we need to basically go in like the 4 directions. So we go right, we go down, we go left, we go up. So here we would say explore DFS row plus 1, call explore DFS, same row, next column, the same in the other direction, row -1. So we go up, call, and then lastly we'll go back, like left, row, call -1. So this would be down. This would be right. This would be left. And then this would be up. Yeah, so down, right, left, up. Okay, yeah. And then, so we explore, and do we, yeah, so because we've like add this in here, we don't need to like do a visit.add here because that will happen here. And then lastly, down here, we'd want to return, am I indented properly? I think so. We'd want to return islands. Yeah.
Okay. Is this your complete solution here?
Yeah, that's it.
Yeah. This code makes sense. It does fulfill the purpose that you explained. It does fulfill the approach that you explained.
Yeah.
But just one thing I noticed, where you computed your num calls and num rows, would you like to double check that? Just at the very top. I don't know if you can see your
All
code.
right. Yeah, numbers.
Yeah.
Numbers would be this, and then calls would be this. Yeah,
Okay.
and then that we are good. Yeah.
All right. Would you like to run through my initial test and see how your code would work with that?
Yeah, perfect. So we started this one. Let me actually just remove the highlighting so we can like basically do it. Right. So we start off iteratively. Um, we start this first one. Is it visited? No. Is it a piece of land? Yes. So the first thing we do is we say, okay, let's explore this island. Um, is it out of bounds? No. We're still in bounds. Have we seen this already? No. Is it water? No. So we would mark this as visited, and then we would return. Oh, we mark it visited, and then we would like explore other directions. So we go down first, and then do the same. Is it out of bounds? No. Is it already seen? No. Um, is it water? No. So let's add it. Then, because we're in a recursive stack, we'll go down again. Is this water? It is. So we just return that branch is closed. We go back to the top. We go right. It's land, and we haven't seen it before. So red. Then we go down again. Not seen before. Not water. Not out of bounds. Red. Down. This is water. So we stop. Then here we go right. It's water, so we stop. Here we go right again, water, we stop. Then, yeah, so here, I think we come back here and then we go right, but we've already seen this before. So we don't go in that direction. Left is out of bounds, up is out of bounds for here. Left is out of bounds for these two, up is out of bounds for these two, and these two already seen before. So we've explored that. Then we continue on to the next one. But one of our conditions here is that we haven't visited it, but we visited it since it's red. So we just keep going. This is water. This is water. This is water. We've seen this before. We've seen this before. Water, 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 water. We start here again. We haven't seen this, so let's explore this island. Let's just use purple here. And we go in all four directions. This is water, this is water, this is water, and this is water. So like there's no point going in any of these directions. And then what we do is we keep on going. Water, 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 water. Let's explore this. We go in all four directions. Just use this. We go in all four directions. And this is water, this is water, this is out of bounds. This is another piece of land, so we go in there. And then in all four directions of this is water. We've seen this before, so we don't go there again. Out of bounds and out of bounds. So, and yeah, basically each time that we started an island, we were incrementing num islands by 1. So this would return 3.
Okay.
Yeah.
Perfect. Okay. I just had this doesn't really affect your code, but in the in where you said explore DFS row +1 call. See where you said down, right, left, and up.
Yeah.
Would row -1 be going left or would it be going up?
Oh, sorry, this is up actually. And this is left.
Yep.
Yeah.
Just a little nitpick. Obviously, it doesn't affect the actual logic of the code. But Yeah, it seems like a pretty solid solution. You came to it pretty fast. So I do have a follow-up question for you in regards to this. We
Yeah.
can just discuss it first, and we don't necessarily have to code it. But I was just wondering, what if instead of returning the number of distinct islands,
Yeah.
we had to return an array which contains the sizes of each island? So let's say now in this case here with our input, instead of returning three, we would return four, one, and two.
Yeah.
Four being the size of this first island here, and
Yeah.
then one being the size of this island, and then two being the size of this island.
Yeah.
How would you change your logic to accommodate this?
I mean, because we're actually this is yeah, okay. So we're using recursion right here for the depth first search. So effectively, the output of this function, we could get it to return the path it follows. So we would first change this variable to, I guess, explored or um, island sizes, and then we'll set this to an empty list.
Okay, you don't have to start coding yet. I just want to
Okay.
hear like how would you think about this?
Yeah.
So
So effectively, we would just use change the output of this depth first search function to be the size of the islands, and then every time we get a case where we've seen more of the island, we would just return the current island, which would be one plus the the surrounding islands, right? So we break it down into like smaller problems, which is around me, how many islands are there plus me, or how many pieces of land are there plus me, right?
okay,
So in this case, we would, or actually, let me run through a problem, right? Here we would do one. This is one. So now it's like one plus how many pieces of this island are to my right? How many pieces of this island are downward? How many pieces of this island are left? And how many pieces of this island are up?
okay,
In this case, we'd start one plus, let's check how many are down. This would ask the same question. It's one, right? All the directions. And then this is one, all the directions. This is one, all the directions. And these directions should return zero because, like, okay, we've already seen them before. We've explored them before. So this would say, okay, there's one around me. There's one around me. There's one around, well, there's one around me, which is this plus myself, two. Um, this would say there's myself, one, and this would say there's one and the ones around me. So we'd have one, this would say two, this would say three, and four.
okay, okay. I
And then
see. That makes sense.
we'd do the same here. So it's like this is water, this is water, this is water. So it's just myself. And then the same thing here. We'll be like, okay, look to my right. I have, look to my right. How many pieces of land do you have? And then it would look around itself and be like, it's just me. And then this would say, okay, well, I'm a piece of land too. So I'm going to count myself and yourself. So two, right?
Okay. All right. How would you change your code to accommodate this?
Yeah, so as I was saying before, I would first start by renaming this variable to island sizes. And I'll set this to an empty list. Next, just for the purposes of this, just to be more clear, I'll change the output of this. So we're returning an integer, which is basically the size of the island. So yeah, probably a better name for this function would be explore island DFS. But that is all right. So return zero here because that means we're out of bounds. So nothing here. We've already seen this. Hey, there's nothing here. There's nothing for me here. And there's water here. So nothing. And then here we would say island size is just me for now, right? Equals one. But let me ask my neighbors what they know about the island size. So island size plus equals island size plus equals island size plus equals, and then lastly island size here plus equals. And then we weren't returning anything before because it was just like a void return. So now we actually want to return the island size. Oh, right. And then lastly, what we want to do is append. I think in Python, it's like add. Add the output of this function to this, and then get rid of this because that variable is no longer valid. And then lastly here, we return island sizes, and here too.
Okay.
Yeah.
Let's see. Okay. Guess that works. Looks good. In Python, it's append.
Right.
But yeah, but minor issue. Doesn't matter.
Add is for sets.
Yeah, add is for sets indeed. Yeah. All right. This looks pretty good. Well done. One last follow-up question. You're getting me too quickly here. You're getting the answers too quickly here. Okay, I have to ask you one more time. One more question. What if we wanted to incorporate diagonals? If you wanted to also account for diagonals, yeah.
Yeah. I guess the only thing here we would make changes to, so the directions that we go in, we would just include diagonals. So like the diagonal here would be row +1, col +1, row -1, col -1, row -1, col +1. So yeah, basically we're just, now we go down, right, up, left. We would just make modifications down here to add those directions that we want to go in.
Okay, so then what would the result be for this input that we have now?
So yeah, I could run through it real quick. So we've done this already. So down, right, left, up, we would include here. So this would still count as one island, but the only difference is here, we would actually go diagonal as well. So this would be red. And then here we would go, this would end up being red because from here, we will find our way here somehow. And then of course, this was part of the previous island. So, and then of course, if we go back, the same base cases apply that we've already seen this. So we wouldn't like start counting that again. But yeah, basically this would all be red. And would you like me to make the like actual code change?
Nah, don't worry. I feel like just your thought process is enough there. Makes sense. All right. Thank you. Well done, Jay. Great job. Pretty efficient solution here. Could you talk me through the time complexity actually of the solution?
Right. So for this, the time complexity would be m by n, which would, where m is like the number of rows and col is the number of columns, because in the worst case scenario would have to go through like every row, and then for every row would have to go through every column. That's it. They were all like once.
Okay.
And then would you like me to talk about the space complexity as well?
Yeah, that was gonna be my next question. So go ahead.
Yeah. So here we have similarly m by n, which would be where like we'd use this like the stack, the recursion stack, right? In the worst case scenario, we would have to run through everything. So that would be m by n as well, the recursion stack.
Okay. If we were to use, sorry, go on.
I said with the recursion stack.
Yeah. Okay, that makes sense. If we were to have used a BFS instead of this, would the time complexity be the time and space complexity be the same or worse?
It would be the same. Yeah.
Could you explain why? How would it be the same? Like how would it be with a BFS?
Yeah. So with the BFS, we could use a queue. So the queue basically would replace the recursion stack here, which we would still have to, in the worst case scenario, we'd have to pop on every single element in the list for each column. Yeah.
Okay, makes sense. All right, that concludes my questions for you today.
All right.
Good job, Jay. You're hired. Okay. All right. So, just before we wrap this up, I just wanted to ask, just for all the people out there that are trying to get into big companies like Google, what is one like a couple of things you would say to them, to somebody that's just starting off that wants to reach big tech level with software engineering?
I would say find a way to showcase your skill set. So that could be through volunteering. I mean, the like kind of typical way people do this is with projects. That's valid as well. But I think like one thing that gets underlooked a lot is like volunteering. Volunteer in your local programming club community. Volunteer your school. Find a way to showcase that like you're good at what you do. And I think if you can teach people something, that means that you probably know that thing, right? So yeah, volunteering projects, any way that you can kind of showcase your skill set, do that. Yeah, that would be my advice if you're trying to get in.
Okay, solid. Thank you so much for jumping on the channel, Jay.
All right.
Everybody watching the video, if you like the video, make sure you like, subscribe. If you guys have any questions about Google or anything, you can leave them down below in the comments, or you can hit up Jay's LinkedIn, which I'll leave in the description as well. And you can also leave down in the comments if you'd like to see any other types of videos with Jay as well. Obviously, I'll give the ideas to Jay and see if he's up for it. But if you guys would like to see any other videos with Jay, just let me know in the comments below. And yeah, thank you guys for watching. See you guys in the next video.
All right. Bye.
Peace out.